students, so after completing the second problem on nth derivative of algebraic function, let's move to the third problem. So here I have one more algebraic function for which we are going to find out the nth derivative. So let's see how to get the solution. So here guys, we have to prove that the value of nth differential coefficient, which is nothing but the nth derivative of x cube upon x square minus 1 for x equal to 0 is 0 if n is even, and the answer is minus n factorial if n is odd or n greater than 1. So guys, what I'll do is, first of all, I'll rewrite the question so that you can understand the question. So here I'll say that if y is equal to x cube upon x square minus 1, then we have to prove that the value of yn is equal to 0. The condition is x is 0 and n is even. So here I'll say n is even and x is 0. Similarly, if n is odd, then the answer is minus n factorial. So n is odd, then x is 0 and n is greater than 1. So guys, we have to find out the value of yn. So there are two questions. So first of all, we have to prove that yn is 0 and then we have to prove that yn is minus n factorial. So let's start. So guys, first of all, if you see the question, then it's a algebraic function. So whenever we have an algebraic function, to find out the nth derivative, we have set of formulae. So I'll show you. So guys, here we have these two formulae which we use to find out the nth derivative of algebraic function. Now if you observe these two formulae, then in both the formulae we have 1 in the numerator, and in the denominator we have the linear function, that is ax plus b or x plus b raised to m. So guys, for that we have to bring 1 in the numerator. Now the question is how to bring 1 in the numerator. So if you observe the question, we have x cube upon x square minus 1. It means the degree of numerator is greater than the degree of denominator. So first of all, I'll divide that numerator with the denominator so that we can reduce the degree of numerator, and then we'll do the remaining adjustment. So it means guys, I have to divide x cube with x square minus 1. Now to divide this x cube with x square minus 1, we always divide the first term of dividend with the first term of divisor. So I'll divide x cube with x square and we will get x. Next, we multiply this divisor with the quotient. So x square into x is x cube. Then 1 into x, that is x, or I'll say minus x. Next, we'll do the subtraction. So the sign of the second function will change. This will become negative x cube. This will become positive x. Guys, next, I can cancel x cube with x cube and here we'll get positive x. So now this is the remainder. Guys, if you observe the degree of this remainder, it is 1 and the degree of divisor is 2. So whenever, remember, if the degree of your dividend, so this is my dividend currently. So if the degree of dividend becomes less than degree of divisor, then you have to stop the division operation. So here I'll stop the division operation. I'll say this is my remainder, this is my quotient, this is dividend and divisor. And then what we'll do is we will represent our numerator upon denominator function in the form of quotient plus remainder upon divisor. So guys, by this form we had value of y as x cube upon x square minus 1, which will become quotient. Now quotient is x plus remainder is also x upon divisor, which is x square minus 1. So guys, this is the value of y. Now for this value of y, we are going to find out the nth derivative. So if I find the nth derivative of x, it is going to be 0 because the first derivative of x is 1 and the second derivative is 0, and henceforth we'll get all derivatives as 0. It means for x raised to 1 we'll get nth derivative as 0. So we are going to ignore this first term. Now if I observe the second term, it is x upon x square minus 1. So if I want to apply any formula, first of all I need to convert that x square in the linear form, because x square is a quadratic form, and for quadratic form we don't have any formula. So x square minus 1 can be written as x plus 1 into x minus 1. So guys, here I'll say it is x plus x upon x plus 1 into x minus 1, and then we have to find out the partial fraction of this, because in the denominator we got two linear factors, and whenever we have two linear factors multiplying each other, we can't find out the nth derivative directly. So we have to separate these two linear factors, and that can be done by the process of partial fraction. So guys, for that we'll use the rules of partial fraction, or we can use the shortcut method. Now what is shortcut method? Here, instead of finding the partial fraction, we can adjust the denominator in such a way that we can get the same value. So see how I'm doing it. So here I'll say, let's say it is x plus, now here we'll say it is 1 upon, let's say, x plus 1. Here we'll say 1 upon x minus 1. Now guys, what we have to do is we have to give here a sign in such a way that we will get this function again. So let's say if I say it is x, it is plus, then by cross multiplication or by finding the LCM, we will get x plus 1 into x minus 1 in the denominator, which is exactly similar to this step. Then if I cross multiply, here I'll get x minus 1, here I'll get x plus 1, 1 and 1 can be cancelled and we'll get 2x. But I want x in the numerator, and that is why I will multiply this bracket with half. So this 2 will be cancelled with this 2 and we can get x in the numerator. So it means guys, this is the partial fraction of x upon x plus 1 into x minus 1. Next, this is the value of y. So we can find out the nth derivative. So nth derivative of x is 0, we'll ignore it, half will remain as it is. So here I'll say therefore nth derivative yn is half. In bracket, the first term is 1 upon x plus 1 and the second one is 1 upon x minus 1. So guys, I'm gonna use this formula. So if I compare this 1 upon ax plus b with 1 upon x plus 1, then a and b both are 1. So just replace a and b with 1. So here we'll get minus 1 raised to n into n factorial. A is 1, so 1 raised to n is 1. Here x plus 1 raised to n plus 1, so upon plus, then we have 1 upon x minus 1. For that again I'll use the same formula, so we'll get minus 1 raised to n into n factorial upon x minus 1 raised to n plus 1. Now guys, from these two functions we can take minus 1 raised to n into n factorial common. So we will get value of yn as minus 1 raised to n into n factorial upon 2 into 1 upon x plus 1 raised to n plus 1 plus 1 upon x minus 1 raised to n plus 1. Now guys, let's see the question again. So according to the question, we want value of yn as 0 if x is 0 and n is even, and we want value of yn as minus n factorial if x is 0 and n is odd and greater than 1. So if you observe both the conditions, then in both the condition we want x as 0. So guys, what I'll do is here, first of all I'll say let's put x equal to 0. So we'll get, so here I'll say put x equal to 0. So here we'll get yn of 0, because guys let me tell you that yn is nothing but yn of x, because since the value of y is in terms of x, we say that y is a function of x. So we can call it as yn of x. So if I put x as 0, here we'll get minus 1 raised to n factorial upon 2 as it is. This will become 1 upon 1 raised to n plus 1 plus 1 upon minus 1 raised to n plus 1. And now guys, we can apply two conditions. So in first condition, if n is even, so guys, if n is even, this will become even plus 1 odd, and 1 raised to odd is 1. Even plus 1 will become odd, minus 1 raised to odd number is minus 1. So guys, here we are getting 1, here we are getting minus 1. So 1 plus minus 1 is 0. So here I will say, if n is even, then yn of 0 is 0, because 1 plus minus 1 is 0. Now let's see what we get the value of yn of 0 if n is odd. So I'll say, if n is odd and n is greater than 1. So let's see what we get. So guys, if n is odd, then odd plus 1 is even. So 1 raised to even is 1. So here I'll get 1. So I'll write down these numbers. So here yn of 0 equal to. So if n is odd, guys, here minus 1 raised to odd, because n is odd. So minus 1 raised to odd number is minus 1. So here I'm gonna get minus n factorial upon 2. Let's see what we get in bracket. So if n is odd, odd plus 1 even, 1 raised to even number is 1. So here we'll get 1. Next, odd plus 1 is even, minus 1 raised to even is positive 1. So here I'll get again plus 1. So guys, 1 plus 1, 2, I can cancel with this 2, and we will get answer as minus n factorial. So guys, we'll get value of yn as minus n factorial. If you observe the question, then we have proved that value of yn is 0 if n is even, and value of yn is minus n factorial if n is odd. So here we get the final answer. So guys, I'm sure you understood the video. So keep watching all the videos, because in the next video I'm gonna cover one more numerical on successive differentiation. And guys, don't forget to share this channel with your friends, because they can also get benefited through such wonderful videos of engineering, mathematics and other subjects of engineering. Thank you very much.